Welcome, everybody. Good morning, good afternoon, and good evening to all our viewers all around the world. My name is Ronit Mukherjee, and I'm a part of the Global 3D Experience Work Simulation team. My good friend and colleague Shri Krishna and I are thrilled to have our SOLIDWORKS Cloud Simulation champions in the house today as we kickstart our new series that we're going to put out. This series is called the SOLIDWORKS Cloud Simulation Champion Series, and you can register that in our the web page. There's a link. There should be a link for the chat for that web page in our chat as well. If not, please note down the IDs and the web page address, and please go and register to this new simulation series that we are very happy and excited to bring to you. Now, Shri Krishna, you want to go ahead and introduce our guests today?
Yes, first of all, hello everybody. Very excited to be here. And as Ronit mentioned, this is going to be our monthly webinar series where we are bringing in SolidWorks champions who have successfully adopted the cloud simulation and realized benefits both in terms of engineering and also in terms of business benefits. And to kickstart this session, we thought QARGOS would be a perfect fit. For those of you who watched 3D Experience World either from your virtually from your laptops, phones, or physically attended the event at Dallas, QARGOS was a big name in the event. And the reason is that our friends Alok Das, who's the co-founder of QARGOS, and Pranav Shinde, who's the lead vehicle integration engineer at QARGOS, they have really imagined a new generation vehicle, a new class of vehicle, all with the power of 3D Experience Works portfolio. So I'm not going to reveal too much at this point. I'll let Alok and Pranav introduce themselves. And by the way, for those of you who don't know me, my name is Shri Krishna Chittur. I lead the worldwide go-to-market efforts for 3D Experience Work Simulation portfolio. Very, very excited to be here. Ronit and I are looking forward to this amazing series. With that said, let's go ahead and get started. Alok, please go ahead and introduce yourself to our audience.
Well, thank you, Shri Krishna. Thank you, Ronit, Ramesh, Jill. Thank you so much, the Source System team, for this amazing opportunity to be part of the great series of webinars. It has been an amazing journey, past several months since the 3DX world. The life has been extremely busy and occupied with reference to the product announcement that we did at the amazing 3D Experience World 2024, which happened to be the 25th event. And it has been an amazing journey so far. Thank you so much for making us part of the webinar series. We are very happy to be part of it. My name is Alok Das. I am the co-founder of QARGOS. We are working towards advancing the world's transition to sustainable logistics with our first product, which is the QARGOS F9, and we'll be talking about QARGOS F9 and the journey, the way we have leveraged 3D Experience Works for developing this particular solution, which is one of its kind and first of its kind in the world.
All right. Thank you, Alok. Pranav?
Yep. Hello, guys. My name is Pranav, and I'm looking after the vehicle development at QARGOS. I look after research, development, simulations, testings, and a whole sort of stuff. And yes, as Alok said, it has been a great journey to be part of 3DX World 2024. And for us, it might not be too much to say that life was different before 3DX World and after 3DX World. So a lot of things have changed, and it has been a technological intensive journey, and we are still progressing on it. Meaning we are still on that path going forward. And yes, looking forward to a lot of innovative stuff and simulation-driven design changes at QARGOS.
Okay,
Brilliant.
thank
Welcome,
you.
guys.
Yes.
Yeah, welcome. And let's get started. So, first question to you, Alok. Tell us about the problem that you're trying to solve. What is the kind of ambition of QARGOS?
Sure. So let's talk about QARGOS and the associated market. So several years ago, when we started working on the electric vehicle development, the premise was to look at what exists in the market Are we going to focus on the consumer segment, or are we going to focus on the commercial segment? We started looking at different opportunities. We knew that the B2C space, the consumer space, is going to be extremely competitive, but at the same time, the solution or the product that we are building should be solving a large problem, and it should not be just India centric or one market centric. It should be a global problem on its own. We spent about 3 years understanding the behavior of people, how they use different mobility products for the commercial application. And that's where, in another way, to explain that, on the left side, you can see on your screen that there are different forms of two-wheelers. Like, there's a consumer centric product, like, a cruiser bike or a commuter or a sports bike. And these products were specifically designed for the application. A sports bike was designed for a high speed and things like that. A commuter was from point A to B. At the same time, there are some commuter vehicles which are also being used for some form of logistics application. I'll not specifically talk about delivery application. Delivery is just one part of it, but people use their vehicles for different form of commercial application. They are good enough, but they are good for the limited capacity, like 20 kgs, 100 liters of space. And on the right side, we have the vehicles which are like three-wheelers and four-wheelers kind of a thing. But then when we talk about specifically a compact footprint product, which can be used for multiple application, and that's what exactly we are working on, a compact logistics vehicle, a CLV which can do more for less. It's a proprietary architecture, ensures very low center of gravity, which would allow having a large space in a compact footprint. So that's what we are calling as a compact logistics vehicle, a cargo scooter platform. We had to reimagine everything about how a two-wheeler engineering has to be done with the load, so that the overall center of gravity of the vehicle is pretty low, and it keeps the vehicle much more stable, dynamically stable, and sorted as well. The key thing is that we have embedded 225 liters of cargo space and 120 kgs of payload, which does not include the rider. It basically is only focused on the cargo segment. And this particular journey has been amazing. About there has been learnings during this process, challenges. You can also call it a serendipity. We have discovered new things with this particular platform architecture that we have invented.
So tell us a little bit more about the product, the vehicle itself.
Yes. So when we started building the product, the idea was that a vehicle has to fit rightly between a two-wheeler and a three-wheeler. So we optimized that, when we started experimenting a lot about how much is good enough for a two-wheeler to carry. So 225 liters of a space was the most optimized volume that we discovered, that, this is the most optimized, which will not hamper with the dynamics of the vehicle, and 120 kgs payload. All these are physically tested and scientifically driven. It's not like a random number like 225 liters and 120 kgs of payload. It has got a low center of gravity because the cargo, as you look at it, it's actually located between the two wheels. It's not like, in the front loading, it's actually between the two wheels. It has got a realistic range of 150 kilometers with the payload. It is not a standard test condition. One of the key things which I must tell, that when the vehicle is being used for logistics application, it's going to go from point A to B, C, D, E, F, G, H, and overall. So the utility of the vehicle or the total cost of ownership is driven by the amount of kilometers or the number of kilometers that you can do on any given day. So that's how you're going to, the ROI is return on investment that's going to reap. At the same time, you cannot make a slow speed vehicle, because logistics is directly proportional to the speed of operations. If you make a low speed vehicle, then it becomes a problematic thing. At the same time, when we talk about left on all four left, they were challenges. At the same time, they are the specs of the vehicle as well. So you have to make a vehicle which has got 225 liters of space, 120 kgs of payload, low center of gravity, 150 kilometer range, and it should be capable of going very fast. While we are designing a vehicle like that, you also look at added benefits or the technologies that you can integrate onto the vehicle, because this is the day of tech. It has got to be a deep tech platform which allows one to leverage the power of technology. So crash detection or riding analytics or route optimization, vehicle and cargo tracking, because the vehicle might be also at times carrying expensive cargoes, which are more valuable than the vehicle itself. So the traceability and the tractability becomes very, very important.
All right. And you always mention that it's not a single vehicle, it's rather a platform that is meant to do several things. Can you elaborate a little bit on the versatility of the platform?
So yes, thank you, Shri Krishna, for asking that question. So when we started understanding the different market requirements, we realized that only one segment is not sufficient enough for the exploiting the full potential of this particular platform. So we have to build it so that it is modular enough so that it can be customized for different applications. So on the left side, you can see different applications for maybe it is being used for the e-commerce, or let's say a stationer, or maybe a grocery delivery, or it may be a technician, or it can be anything, or a laundry services and things like that. So when we started building our solution, we built it as an empty space which can be optimized or customized for different requirements, like refrigerated compartments. So this is a huge potential about 150 liters of cold chain solution. Let's say for the perishable goods like the meat delivery or the portal delivery and things like that. The perishable products, milk products, or fish, or medicines and things like that. So those kind of stuff can very well be used. This is a compact vehicle. It's a business on wheels. A lot of small and micro enterprises might want to leverage this as a way to earn a living. It can be a roadside assistance and parcel deliveries. So it basically goes to our imagination. Other day, I mean, I was interacting with a person from Dassault System, and he said this vehicle can be customized with the mesh door so that it can be used by pet parents, right? So you can actually have your pet inside, sitting inside the vehicle, and you can move around with your pet inside this vehicle. So there are, a plethora of application which we have not even imagined at this stage. And I'm sure that people are going to, as this vehicle comes out on road, people are going to find a great use for the vehicle in solving their problems, day-to-day problems.
And I believe it's fair to say that the vehicle is not just designed for last mile delivery or first mile delivery. The number of applications are kind of unlimited, and based on the way you guys have imagined the design.
I mean,
Absolutely. And in fact,
the pet idea is fantastic. I mean, yeah, this is great.
yes,
And
in
in
fact,
fact,
cargo
Ronit,
safety is important. Cargo safety is
yeah,
very, very important part of it. So that you can, lock it. You can lock the stuff inside it, and you can easily walk away without being bothered about the theft.
One
right.
quick question, Alok, and just a comment. The first, the slide on the right, the image on the right, I see is a refrigerated component. That means it's an AC chamber for the pets too. So this is great. I mean,
Absolutely.
It's funny we are talking about pets as a potential application. When Alok and Pranav met with Bernard Chalice, the top boss of Dassault Systems, the joke he cracked was, "This vehicle is so well designed. I would like to carry my grandkids in the cabin compartment because it also had glass, as long as it is ventilated, obviously." And and that's probably a perfect segue for us to quickly talk about the fact that the vehicle was launched at the Dassault flagship event of 3D Experience World 2024, right? How about that? I
that was
mean,
awesome.
this was awesome. And on the left hand side, what you're seeing is our very own Bernard Chales exploring the vehicle. And this vehicle was launched as a part of a simulation domain session in Dallas. It was very exciting time because the vehicle was showcased all over. And for those of you who don't know, right now this very first full version of Cargos, or first model of Cargo, is actually at our Waltham office in the customer center. So on the right hand side, you see Manish and GP standing next to the vehicle, next to Alok and Pranav, who are there at the office. Yeah, so huge congratulations to you guys to be able to launch the vehicle at such a large scale at an event like 3D Experience World.
Yeah, fantastic work.
Absolutely, Shri Krishna and Rohan. It has been actually a dream. A lot of times when I look at the photographs now, and I'm honestly telling about it, it looks like a dream, whether it really happened or not. All thanks to the source system team, and I still go back 5 years ago when we made the first sketch in SolidWorks, and to this level where we have actually introduced the product at the 3D Experience World 2024. It's going to be written down in the history that we did our first product announcement, and actually we came out of the stealth for the first time in public domain. So prior to that, we had been testing the vehicle for quite a long time. The customers have been very, very large logistics customers have been testing this. Very, very well-known brands across the world, which we use day in, day out, are already using the vehicle or they have tested the vehicle. And this is the first time we did the public announcement. The event itself was very, very electric because it's such a magnanimous event. I never felt like it was a technical conference, and it felt like as if it was a rock show. So all thanks to the Dassault system for providing us this particular platform to showcase our dream project and take it to the world.
Yeah, I mean, we are still reminiscing some of the moments from this year's 3D Experience World. I guess that kind of also brings up the point that you had the opportunity to announce this product to over 100 plus journalists from different parts of the world, right? And on the left hand side, we are seeing a picture of you guys with me kind of sneaking in, and with Bernard. How was the feeling when this product was announced, and when you guys
It was
met
an
with
amazing.
Bernard?
So it was an amazing feeling because looking forward to the talking to having a personal interaction with the leadership of Dassault System, amazing experience. He appreciated the kind of effort that has been taken in terms of developing this particular product. And apart from that, of course, the press conference can never be forgotten. More than 100 people from across the world, from the east to the west of the world, were present, and they have written about it. There's a lot of media coverage that happened, which brought a lot of positive attention to overall product that has been developed. And the Dassault System Association has been the most critical part of it because people have actually taken it very, very seriously about our association with Dassault System, and we really cherish this relationship.
No, this is fantastic, and it's likewise. So I'm a little curious. I've got a couple of questions, Alok. So you mentioned all the problems that you guys saw, and and to be able to bring a product like this out to the market, it takes quite a lot of work. And you guys addressed the challenges that you guys were running into. Now, why did you choose the 3D Experience Works platform and the tools, when you guys did to work on this project? I mean, you guys had probably other options to pick from too. Why did you guys, head towards the 3D Experience direction?
Sure. First, two specific reasons I would like to talk about. So I come from in my previous organization. One of the things that was imbibed deeper into our minds and overall daily culture, the culture of the organization was the analysis first approach. So I have been brought up as a professional, as an engineer, as a manager, or as a contributor, as analysis first approach. In my previous organization as well, we definitely saw a lot of times engineer face challenges in terms of the integration of the softwares between, or the seamless movement of the design between the simulation software and the design software. So when we started understanding more about the 3D Experience Works, one of the things that was the beautiful part about is that it has been well thought of from the point of view of the seamless interoperability between the different tools and platforms which have been well integrated. Now, as a startup, when you are running with very, very limited resources, one of the things that becomes important is that amount of time and efforts that you require to learn set of things and then get it done. For a large corporation, it's very easy that you can always deploy more number of resources you have more resources at your disposal. You can hire and you can have more number of people who can handle different set of things. But when you are in a part of the startup and the focus is not on only handling the software, the focus is on output, because the customer is the speed of operations, or the speed at which you operate is one of the most important element of being a startup. And that's why startups are disruptors. So when we started building the product, the idea was to leverage software applications, softwares, which allow us to get things done much more faster. The ability to learn and use the software has to be very, very important to be able to deliver that. Well, the key thing when we started learning more about 3D Experience Works is that the seamless integration. And overall, when we don't talk about the cloud or the multi-physics, that is very much possible. At the same time, the kind of the idea is that a user should not be spending more time in learning a software. He should be spending more time in building the product. That's what, and the multidisciplinary approach, or even the latest version of the software being available to you, the right it is the moment it is available on the cloud. So the most latest features that are available. So all those things put together, I think, gave us the power to harness the power of modeling and simulation on an integrated platform. So now that's what we are, as we call it, a ModSim approach.
No, this is fantastic. No, great. I'm actually very curious to know from our viewers, like, how many of us that are watching the webinar right now, how many of you guys actually use simulation right now? Let's do this. Let's launch a poll. Let's launch a poll to see what do you do these days for simulation? If you run any simulation, if you do, or what are you doing? So you should see a poll that should pop up in front of your screens right now. It'd be great if you guys can give us about like 10-15 seconds to answer that question. We'd love to get some answers and some insights from your end.
Yeah, I guess what we are really interested in knowing is for those of you who leverage SolidWorks for your design, how are you validating those designs? Or in very simple terms, how are you currently testing your products?
One of the very important point, Ronit, is that when you start building something which has never been built, whatever you build becomes a benchmark for yourself. And when you are having something which is a benchmark itself, you just cannot get into the iterative mode of build, test, break, or build, base, test, and all those kind of stuff.
Yeah.
The idea is to reduce the number of prototypes that you should be building on, because hardware is expensive, right? And you cannot get into the iterative mode. So leveraging the ModSim approach allowed us to minimize the iterations. And in fact, as we always proudly say, that harnessing the power of simulations has allowed us to minimize the overall cost that has been spent, the dollar that has been spent into building the prototypes. We have spent very, very minimal amount. And that's all because of the modeling and simulation approach.
Oh, that's great, man. I mean, I would love a little bit more, like, a quick overview of how you use the approach to, how adopted QARGOS, and kind of do a little bit more deep dive into some of the issues that you guys were running into. That'd be great. Maybe that's, for down the road, but yeah, this is fantastic.
I guess you could still provide us with a high level overview of the ModSim approach adopted at 3D at QARGOS. And by the way, before we jump in, according to the poll, it looks like a good portion of our users are leveraging either simulation or physical testing.
Oh, that's great insight. I mean, there's still some that are doing outsourcing the simulations and some hand calculations like we used to do back in the day. We might need to have a conversation with them.
Yeah.
Cheers. Thank you for that. Guys. Yeah, thank you for running that poll and answering those questions. We appreciate it.
Sure. So let's talk about when we started doing the QFD, the quality functional deployment. We started understanding what are the customer requirements and need. Example is that the vehicle is going to be out on road for many more hours every day. So it has to be safe, reliable, and durable. Rider comfort and maneuverability becomes very important, because you're going to be having 100 kgs of, or say about 200 pounds of load inside the cargo bay. So the maneuverability, the rider comfort, he should be feeling very, very easy to ride it, even with a heavy amount of load. Performance and range becomes very important, because you want to get things done faster. Large and modular space, and total cost of ownership, because at the end of the day, it's a business which has to recover the return on investment, right? So on the left side, what we see are the key specs requirement, which was basically translated from the customer wants and needs. How does it translate into the overall on the right hand side? Let's look at it. So basically, when you want to have a safe and reliable solution, you are talking about a stronger chassis which does not break down, right? And it has to be out on road, and it has to be out on road every day for several hours a day. It has to have a lower aerodynamic drag, because you're trying to make a fast vehicle. You are trying to make it a more integrated vehicle. So the aerodynamic efficiency becomes very important. Safer batteries, it should not catch fire, because if it catches fire, the cargo is also getting burnt, right? So safer batteries. At the same time, the overall manufacturability of the parts, the injection molding simulations and all those things, which allows you to do it right first time, the analysis first approach, corrected vehicle platform, the electromagnetics, or the smoother ride. So all these on the left side translated over to some of the key technical requirements for the vehicle. And by leveraging 3D experience works, what really allowed us, we'll be talking about that in a detail, So the idea was that it allowed the integrated environment allowed us to get a lot of these things done at a design phase in a much more optimized and much more seamless fashion. Whether it be, we are doing a real-time design review, we need not be present in office, you can do that remotely. The structural integrity and durability, the structural analysis that can be done in Abacus, it can be seamlessly transported between the SOLIDWORKS and the Abacus very easily. The aerodynamic efficiency, drags and things like that, which we're going to talk about, or the injection molding. So a lot of these studies that we have done, the overall design that we have done, it has all been very much possible to get this thing done faster with the help of the 3D experience works. I must also tell you, when you talk about large organizations like, let's say, Honda or Yamaha's, they would be having hundreds of people doing all of these activities. But when it comes to a startup with a limited set of people, the overall execution has to be very, very intense. And that's where the software plays an important role in terms of minimizing that cost and also getting it done much more faster.
No, this is great. One thing I do want to remind our viewers, I mean, this is some great information we're getting from Alok and, Pranav. It'd be our Q&A session, that session looks a little empty, guys. If you have any questions, please, write it to us. We'll address these questions towards the end of the webinar. But just bombard us with your questions. We'd love to hear from you and see what all we can answer for you.
Yeah, absolutely. And in fact, Alok and Pranav, to your credit, you guys have truly democratized simulation. Based on what we have seen, your designers working on different subsystems are using different kinds of simulation in parallel with SolidWorks, right? Your heart of your modeling is obviously the SolidWorks technology, but you guys have deployed various kinds of simulation workflows for designers. So now is probably a good time to kind of switch gears and hear from Pranav about one of the major applications and the methodology that was developed during last year in terms of aerodynamic prediction and drag prediction. So Pranav, can you elaborate a little bit about why is this important, especially for this class of vehicle, and how did you guys go about addressing the challenges?
Yes. So, as Alok has already mentioned that when this particular platform was built, we essentially didn't have any benchmark kind of thing, right? So it was very difficult to understand how this new platform, this particular form factor will be affecting, the ride and handling, and what kind of motor sizing has to be used for this particular vehicle, because this can carry loads from up to, 0 kgs to as high as 150 kgs. And you could have multiple load carrying scenarios, multiple applications, and to design one particular motor, one size of battery pack which can cater to multiple applications is a little difficult. So we have to narrow down to our requirements and understand what are the best ways to design and fix the sizing of the components. Similarly, when it comes to the body panel profile, so there was kind of a trade-off when to think about how less the drag force has to be and how aesthetic the vehicle should look, and at the same time it has to be functional. You need doors to open the cargo, you need to have accessibility to entry and exit of the cargo, And this brought us a curiosity in our mind that let us do a full scale simulation of the vehicle. And it will give us a lot of inputs on what the drag coefficients are, how the air is flowing across the body panels, across the rider, and then design or redesign the body panels as per the requirements. So then we thought of going to the simulation approach. It's basically because so traditionally, if we have to do that, it would have been a very lengthier process, right? So basically, we do a clay model of it, then we try to 3D scan it, digitize it, and then build a 3D CAD model of it. And this itself is a very lengthy process. Then we do simulations on it, and then once we are happy with the simulations, then we go to the wind tunnel test, and then kind sort of understand how the design is going to affect the performance. And if at that point we understood that no, something is wrong, it's not as per the design intent, then again we have to change the design, do again the clay modeling, and repeat the entire process. And this is going to take big amount of time, and a lot of cost is involved in this. So then we thought of going to the approach of what we called as digital twin. So you basically build the 3D Works SolidWorks CAD model, and you directly push by one click to the platform. And there you do a lot of simulations. You assess the body, you assess the airflow across the your model. And then if you feel that there is somewhere the flow is not uniform, there is a lot of turbulence created, the air is not flowing as per intended, you again go and do the change and then come back to simulations right away. And this kind of shortens the CAD modeling and the simulation aspect. Once you build, then you can build a single clay model, and you can put into internal testing. So by this process, you don't there is no there's it's not required to build multiple clay models as such. You just do all your iterations in the digital twin, and then you build one particular clay model, test it, and validate your research. And this is the same platform where we use or where we build the entire SOP to do the simulations, which we'll see in the next slides. But this helps to accelerate the product development life cycle in a super fast way.
No, this is great, Pranav. I mean, I
Yeah.
saw the image of the gentleman making the model of the clay car.
Yeah.
Given my creative abilities, that will take me all my life. I cannot do that, and to be
It's
able to do that
internal.
into SolidWorks that smoothly, it's much better. Not even that. I know that I've back in the day I was just looking for some wind tunnel testing to be done on a motorcycle, just a personal project, and just kind of getting like quotations of how much it costs to do a wind tunnel testing. Oh boy, yeah, that personal project just remained a personal project. It never really expensive. So
True.
so this is
Yes.
this is great.
I mean, to get even the access is difficult. Forget about the cost. That is secondary.
Access,
Very
Yeah,
difficult.
exactly. Yeah.
because it's not just about putting something in a tunnel. There's also a lot of pre-processing work that goes into picture, right?
Correct.
And even building the clay model is so expensive. There's a specific kind of clay that is used to build these models, and that clay is very expensive, by the way. And when you build something for a wind tunnel, there's the instrumentation, and it's very cost and time intensive. And what Pranav described just now is the perfect usage of simulation, which is not necessarily to replace physical test, but
Yeah.
to reduce the number of physical tests in order to get it right the first time, and release the product faster to market.
Yeah. I mean, first time right is what many we should focus on to reduce the costs and improve the design process.
Of course, yeah. So
Yeah, and this particular slide, we can see, this is a typical Morsim approach for drag prediction. So basically, we develop the CAD model in SolidWorks, then we push it to the fluid model, then we build the scenario across it. In scenario, basically, we decide what kind of air medium it has to pass through and all those things. We then give the mesh definition to it, which we'll see in the later slides. And then we do the cloud compute of it, and post this, we at the sixth step, we generally see the results, right? And the one particular and interesting feature here is if you feel that results are not as per our design intent, you can go back to the step one, you can make a change, and then directly come back to cloud compute and hit it. So it will automatically calculate the new simulation results. You don't need to repeat the step 2, 3, and 4 again. So this
So
is
that
one of
saves
the
a lot of manual time for
yes,
your
yes,
designers, right?
exactly. Yeah, yeah.
And also, Pranav, is there a need for data exports or imports, or is it just a simple save and push and it goes
I
pretty?
mean, no, not at all. Meaning in the previous, last time when I used, meaning of 5, 6 years back, there was a lot of issues which used to happen when you transport the CAD model to our simulation software. It used to always throw some error that there is a line missing, there is a surface stitch issue, and all those things. But in this case, since the platform is integrated so tightly and so neatly, it takes care of all these issues. So a lot of time is saved in the geometry cleanup stage alone. So
Great.
that stage is very much troublesome for all CAD engineers and simulation engineers.
That's
That's a
great
very
to
good
hear.
point.
Yes,
In fact, in the world of CFD, about 60 to 70% of the manual time is spent on just cleaning the model, getting it ready for simulation. So you bring up a very good point, Pranav.
yeah,
Tell us about one of the key
yeah,
things that was done on the SolidWorks side to extract the frontal area.
yes. So just a couple of days back, I was talking to one of the motor supplier, the hub motor supplier, and he asked me what is the the surface area, the cross section surface area, and I quickly went on to the our presentations and paper that we are publishing, and we gave him the value immediately. So I mean,
Right.
this would have been very difficult to calculate in the physical scenario. But in SolidWorks platform, you get a silhouette curve entity selection tool wherein you can project all the entities on one single plane. And once you stitch all this thing, you get this surface area, which is projected at one particular plane. So this is helpful in understanding how much of the drag force is going to act, and it will also calculate the coefficient of drag. So for example, you can see here with rider, the surface area is somewhere around 0.83 meters square, and without rider, it is 0.53. So this gives a very good understanding about how much of the drag forces are going to be caused because of the vehicle alone and also the rider. We can see it in the upcoming result simulation. But one particular aspect here is that the more the frontal area is, the more the drag is going to be. That's the kind of intent that we tend to have it from this particular slide. Yes, and this is one a basic thing where we do in the simulation is when we are doing a aerodynamic study, we need to have a wind tunnel in place, right? And this explains a kind of a virtual wind tunnel that we are building. We create the exact similar wind tunnel into our simulation software where we give us the length, the breadth, and the height of the wind tunnel dimensions. These are basically designed with the help of the field industry knowledge that we have or the experts that have. And then we kind of, give particular boundary conditions. For example, the walls are no slip boundary conditions here because if it is slip boundary condition, you will be getting very bad results because it will assume kind of, your vehicle is running in between only those particular walls. But in real life condition, you have, atmosphere all over. So you have to be very cautious about giving the boundary conditions for the walls selected.
So
And
this virtual wind tunnel model is intended to simulate more of a real world condition.
Yes,
And
exactly.
eventually you're going to have a virtual wind tunnel model that replicates the actual physical wind tunnel.
Yes, yes, exactly.
that reminds me of when I was new to simulation back in the day, and my mentors were very keen on emphasizing the fact where when you're setting up the simulation, it has to be very close to what the real world scenarios is.
Yes,
So the
exactly.
the sentence that came out was garbage in, garbage out.
Yes.
That's what I've learned, So
Yes,
so we want to make sure that the stuff that's going in is actually replicated in the real world, and to be able to get the proper answers correct.
yes, yes. Yeah, so just connecting the previous slide. So you can see a vehicle over there in the front and the first zone one, right? So this is the length that we have decided for the wind tunnel. Now, suppose if you shorten the length of this wind tunnel, you're not going to get desired results. And that's
So
why, and that's particularly because there has to be multiple elements zoning done for the meshing. So currently, if you see, there are almost 9 zones. It starts from zone 1, zone 2, and goes to zone 9. And you can also see there is a difference in the mesh size and element size.
So
This
Pranav, this
particularly,
is the
yeah,
volumetric refinement zones within the virtual wind tunnel in
correct.
order to capture the wake which has
Yes.
direct impact on the drag calculation of the vehicle, right?
Right. So the solution has to get converged by the time it exits from the last plane on the right side. So if you kind of shorten the tunnel length, you're not going to get the same pressure as it was in the entry.
Correct.
So since when you're driving on the road, the pressure is atmospheric all over. But if you truncate the tunnel, your pressure exit is not going to be the same, and therefore the in is not going to be exactly as the out pressure, and you will get very different results in onto your CAD model. So it's very essential to ensure that the flow is passing through the vehicle and it is going down and it is kind of normalizing with the atmospheric conditions.
And we see that there were a lot of mesh independent studies that were done in order to ensure that you have the most optimal mesh
Yeah.
that is producing the right results, and the results are not changing. But we also
Mm.
notice that the mesh sizes are pretty
Yeah.
crazy, any
Yes.
around 50 million elements, and it's quite typical for aerodynamic
Yeah.
simulations, not just this
Mhm.
vehicle, right? I
Yes.
guess cloud compute helps in scenarios like this.
Definitely. I mean, that's where there is, as we say about our F9, do more with less. This is similar to do with the cloud computing. You can do much more with less resources at your hand.
Very good point. um let's talk about the results.
Yeah. So
Yeah.
these are the pressure plots or at different velocities. But now at 6 meters per second, at 8 meters per second, and 11 meters per second, at different speeds we try to do this. Now one can see here that we get three typical high pressure plots. One is onto the rider, one is on the front console area, and as the frontal area where the headlamp and the suspension mount is. Now, when we suppose if we try to do this in the real world scenario, we could understand that the vehicle is having higher drag force, but it would be very difficult to understand which part is contributing how much, right? We could say, yeah, it's on the hunch that yeah, the front wheel is contributing much and this is contributing that much. But in particularly in this simulations, we can get the exact contribution of each individual component onto the mounted on the vehicle, and that gives us uh, freedom to quickly decide what part has to be changed. For example, you can see here that the percentage of the forces coming onto the mannequin and the whole model is clearly indicated at info forces. Right now, here obviously we cannot change the rider, but we can definitely have full control to change the vehicle body panels and modify the design. Which can bring down the drag. And that's what we did in the next slide. So we especially thought about changing the pressure on the console, where it was a very minor change, and the change was done very quickly, immediately. And this change did caused or did brought down the stagnation pressure zones, and it did improve the drag forces. I mean, it was very uh, how to say, the decision was taken very quickly because of simulations, or else it would have been very complicated for us to think about what part to change. And intuitively we might not understand that this is going to affect much, right? Looking at the
Mm,
part, there is not much change as such. It's just a
yeah.
sharp fin to a slope kind of thing. We could have thought about changing some different part, but
No, I think that's a very good point, because in structural simulations you can kind of guess what could be
yes,
the areas where this part could break, depending on where the loads are applied, depending on where
yes,
the constraints are. With fluid or electromagnetic simulations, the results you get is typically somewhat non-intuitive,
yeah,
unless day in and day out this is all you're doing, which is a different story. What you're trying to do is adopt a or build a new aerodynamics workflow to a new generation of vehicle, right?
right,
So
right,
what you're saying is this was the least aggressive change that
yeah,
you could adopt quickly to get a,
yes,
improvement in the drag production.
right.
uh, what about the frontal portion?
Yes, so this was obviously the most contributing factor in the drag forces. But when we tried to do the design, it turned out that it's going to be a costly thing to change this particular design or implement this particular change, because this affected many other child components.
Mm,
And secondly, from industrial design point of view, there were some negative feedbacks. So we thought of,
mm,
say, let's park this. Let us again try to redesign the front section taking into care the industrial design and other component packaging in that particular area. And yeah, this is still in progress, but we are going to do it in the phase 2 of this project, where we try to simulate multiple different designs on the front panel and try to reduce the drag at the front.
Okay, very
Yeah.
interesting.
Yeah, and this particular, it's a very beautiful slide which shows the streamlines coming from the front side, and then there are also at an angle the streamlines, and this exactly shows where the negative pressure is. So just behind the rider, you can see blue contour lines which show the negative pressure, and you have some higher red color lines which shows the higher pressure zone. This kind of gives a second thought or second hand to your intuition that how the air streamlines are passing through. And the streamlines do help a lot in understanding how the body should be contoured, how the industrial design has to take place. I mean, we can share this to our industrial designer guys, and they can then design the body panel around it. So it is also helpful for those guys to design the vehicle.
Right. And you've also used this methodology or developed methodology for crosswind aerodynamics, right?
So we did it for crosswind because the crosswind is very important in terms that the vehicle can be impacted by crosswind because of its form factor. That's one. Second, we can have a lot of gust of wind coming from multiple angles when there is a windy day. The truck passing by can impact on the forces acting on the vehicle. So it was very important to study the crosswind, and also given the fact that the vehicle is a high-speed vehicle, it's not a low-speed vehicle. So we have to study the crosswind very carefully. In fact, we are still studying it in much more deeper level to understand whether there are many more effects. So here you can see we have only studied for 15 degrees, 30 and 45-degree angle. We are in fact thinking to study about the 90-degree angle. A complete horizontal wind force coming onto the vehicle.
And I guess studying these multiple configurations is very easy for you because your modeling and simulation are connected to each other.
Exactly.
You change the angle in SOLIDWORKS and then update the simulation model on the platform or
Yes.
vice versa, right?
I mean, you push to cloud and you forget it. You come back after a day or 2 days and you have the results at your hand. That's the
I
easy.
love that you push to clouds and you forget it. That should be it. No, this is fantastic stuff, Bruno. And I'm really excited like how you guys make design changes and how it improves your products. But it also has to speak volumes of how it has a trickle down effect. So for example, that shark fin design that you have, if it's a plastic component that you're working with, now you have to make a design change, and let's say if you have a mold that's already made, then you have to make mold changes as well.
Yeah.
But in this case, you don't have a mold yet, so you can make
Yes.
whatever design changes without affecting a mold. So, and when you go and you run your plastics analysis and you go make your first prototype, and you voila, you're good to go. So that's impressive, man. That's really impressive.
Yes.
Well done.
Yeah, sure.
So, so let's talk about some of the key takeaways from the
Yeah, I mean,
aerodynamics work so far.
we did this virtual wind tunnel, and today we have a full developed established procedure for doing the simulations, and we are that and this is where we are trying to do multiple simulations still. There are a couple of things that we need to take care of in this vehicle. That is the crosswind at a higher angles, and second is the battery cooling, which comes from the front. So we are doing that with the established procedure that we already have. Um, that is the next activity that we're doing. But in this particular simulations, we did achieve a reduced drag force of 15%. And one important uh, understanding we got is that the crosswinds are not destabilizing the vehicle, because
Okay.
we always had the fear that this could happen in this particular vehicle. But yeah, at the speeds that we are designed this for now, it's very much stable.
I think one of the nice things is instead of putting a scaled model in a wind tunnel in a controlled environment, you're actually doing the simulation work on a full scale model, and you're
Yes.
grabbing physical data by putting sensors on the actual
Yes,
vehicle in the real world driving conditions. So
exactly. Yeah.
that's awesome.
No,
Yep.
this is fantastic, man. Great stuff. So yeah, my next question was I was a little curious. You mentioned battery a couple of times, and this is an electric. Anytime we're talking about electric, battery is the first thing that comes to the engineer's minds. And I'm sure you guys have put a lot of effort into, this battery design. Can give me or give us and our viewers a little bit more insights on, what were some of the problem statements that you ran into while designing this battery and how you were able to overcome them using the tools that we have.
Right, I know the battery is a troublesome thing for all the electric vehicle engineers. It is the kind of a powertrain of the vehicle which you have to be designed in proper way. So as you saw in the multiple components in the battery pack, you have to take care of the thermal runaway, the thermal pads, the gels that are used, the cells, how the cells have been integrated. Then you have the nickel bus bars available. You have the BMS. And all these factors affect in a different fashion. We will see that in the upcoming slides. So just before that, let us talk about how and why is it required for this thermal simulations to done. Now, just assume, so this particular duty cycle that I'm going to explain. So assume you're driving a bike on your highway and it's generally a cruising kind of duty cycle, right? So you just throttle it, it generally goes down, or you can, so there is not, so the speed variation is not that high. There is no like 0 kmph to 40 kmph, and again come back from 40 kmph to 20 kmph. So it's a cruising cycle. And what happens is this generally is your current consumption is fairly constant and it is on the lower side. And the heat addition therefore is very gradual. So it adds over minutes and hours of time. But the reverse case happens in traffic. So in traffic, generally, you have to brake it, accelerate it, because depend on the traffic conditions, depend on the road conditions. And what happens generally in this is when you bring the vehicle at a zero speed, you have to again attain a higher speed, right? And that's where you need higher torque. And higher torque means higher current. And higher current means higher heat. And that is the instantaneous heat that we are talking about. So this is where the heat addition becomes very sudden in kind of traffic kind of duty cycles. So this is the duty cycle for our particular vehicles driven on the Indian road conditions, and from there we try to narrow down to three particular load cases of different current consumptions, and this is what we solve for finally. And this is kind of similar to what we did for aerodynamics. Ideally both are in the FMK solver, so the flow remains pretty much the same. We build a CAD model in SolidWorks, you put it on and you save it onto your cloud. You develop a fluid model around it. You design the scenario, what kind of liquid you are immersed cooling in, if it is air cooled or liquid cooled. You define the mesh. In this case, the mesh is much more complicated. Then you do a cloud compute of it. And again, when you see the results and you post process it, and if you find that no, there is some kind of thermal temperature drop or it is increasing in some kind of areas, you again go back, you change, for example, you change the thickness of the insulating material. You bring it down from say 10 mm to 5 mm. And then there is no need for again go and do all the modeling and meshing kind of stuff. You just come back to cloud compute, you mesh it, your mesh has been again adapted to your design change, and you get the results. So that's very simple kind of stuff. And here is a kind of a small demo for SolidWorks users, how you can put the battery pack and save it on the cloud. So there are multiple parts of the battery pack, starting from this is FRP sheets, by the way, which help in fire retarding. Then you have the blue color cells, you have the cell holders. You can see in the cross section, there are two stacks. One stack is above, one is the below. And then you kind of push it to the 3D on the platform from here. You just have to save it, and then you open in the simulation model to do the simulations.
And how many cells does these packs typically contain, Pranav?
This can contain so we have multiple variants. We have starting from say 260 cells to 340 cells. It can go even as high as 540 cells if your form factor is less. For example, if you are using 18650 cells as compared to 21750, you have to use many number of cells.
That's good. It's very good to hear, like, the previous example that you were giving us about the aerodynamics, and then compared to this one, they're both fluid problems. The first one is interesting to know how it's an external one where the wind is sort of flowing at you and you want to understand the science behind it. And in this one, you've got the fluid, the hot air, sort of flowing within within your model. So yeah, we
Yeah.
can address both, and of course, use cloud computing to, take advantage of some local, some cloud resources to, fasten your simulation and go work on some other things.
Yes, yes.
Yeah.
And one of the best thing of this particular FMK solver that I like is the assistant panel. I mean, it is one particular thing that shortens down your learning curve for the new engineers. You have all the things at your hand. You can see which point you are not completed. The things you complete, you get a check directly. So you need not to worry about it. And then you can solve it from here on the cloud. And as I said, you just push it, you solve it, and you forget it. You get the results when you come back a day or later. And this is the most beautiful thing that I love about it. The system is free for you to do any other things.
And I think
And
what blew my mind was these are very complex and large models, right? I mean, here we are looking at mesh counts anywhere between 30 to 50 million volume elements. The fact
yeah.
that you're able to run this on cloud, get a result overnight, and explore several cases, that's quite impressive.
Yeah, I mean, ideally, we should only have been doing load case 1, 2, and 3. We didn't have to do for ambient temperature 40 degrees Celsius and above. But then the engineer thought of let's push it for 40 degrees Celsius. Let's see how the battery is behaving at higher temperatures, ambient temperatures also. And then we added case number 4, 5, 6, and then we, pushed it to cloud.
So ambient temperature is the temperature outside the
Yeah,
vehicle
it's
on
outside the
a
battery pack.
particular day.
Yeah. Yes, yes, yes.
Okay.
So
So
it could go
worst
as
case
high as
scenario would
5.
be like a very hot day with a very high current being applied over a long period of time.
Yes, yes, right.
So tell us about the importance of accuracy in the battery production workflow.
I mean, when we talk about battery and the simulations, it is very important to have good confidence on the results that you're going to get, because if you trust them blindly and if you go and build the battery packs and it then blows into a fireball, it's going to be very tough to control that thing. So we did a lot of correlation studies with the simulation software. We built a small battery pack, a test battery pack. We did put a sensor onto it. We then equipped it with IVT sensors and DAQ systems, and then set up the simulations and try to understand how much is the temperature correlation happening. And in this plot, you can see the correlation. The dotted line is essentially the practical result that we got from the sensor, and the solid line is something that we got from simulations. And the correlation is, perfect. I mean, there is not much deviation, and this deviation is it's very minor, but it's acceptable from the terms of there is how residual errors are going to happen, but it's pinpoint, and this gives us a lot of confidence to go ahead and do the simulations on the cloud platform, and then be confident on the design and go and build the battery packs out there.
We have
And this,
1 minute
yes,
left, so maybe we can wrap up real quick. Can you share a
right.
few conclusions from your battery studies?
Right. So in batteries specifically, we have to consider about two important things. One is the accumulation of the heat and the distribution of heat over the multiple battery pack elements. So battery pack has the casing, it has the damping sheet, you have the cell holders and the cell. So important things I have mentioned here in the graph, you have the casing, cell holder, and cell. So how is the temperature distribution happening? So ideally, these two lines should have been horizontally straight, but you can see at the case 1, which is 30 degrees Celsius, you have a small delta temperature between the casing and cell holder. But when you go at a higher degrees of at ambient and higher ratings of 3C, that is the case number 6 red line, you have a higher delta T from casing to cell holder to cell. And this indicates that the heat distribution is not common across the bill of materials. So you have to, something has to be done to bring it common, right? And this is where we thought of going to a liquid cooled battery pack, because this was an air cooled battery pack, which the air was not able to transfer heat from one component to other component effectively. And that was one of the conclusions from this particular study. So the next battery pack that we are going to build are a liquid cooled battery pack, which will ensure a proper thermal transfer from all the bill of materials. And yeah, the conclusion was the delta T, the accumulation was very high. It was almost 16 degrees Celsius, which did proved us risk on thermal runaway. and then the heat distribution that I talked about. And the most important part was that we have established a best practice to do the simulations, and it was validated with our bench test setup. So now we are, completely free of the intensive process that goes into simulation. We can change something, we can run it on cloud, and we can get the results quickly.
No, this is just fantastic
We
stuff.
can do a lot of variants in battery packing henceforth. I mean,
Yeah,
you
once
do
you have
the
the design on the cloud and you have the simulation set up, then you just iterating on the cloud and making one iteration.
exactly.
Like Sri Krishna mentioned, yeah, no, we are towards the end of the webinar. I do want to give, I know we'll go maybe a couple of minutes over, but I do want to give an opportunity for our, to us to answer our viewers' questions. There's not that many, but there's some cool ones. So Simon Thomas, he's asking, are you guys considering hydrogen fuel cells?
Yes, so the answer to that is yes. We have been having a discussion with one of the homologation body in the country, ARAI. There has been discussions around submitting the vehicle to them, and they will basically, then there will be an agreement in terms of, working together to find out the fuel cell. So yes, that is definitely on the radar, but we are right now focused on, getting this particular vehicle out for the production, and we pick up that particular project as the second iteration of that one.
That's great. He's got one more question. I love this question, to be honest. So could the housing surface be converted into PV panels and continually recharge the batteries without impacting the structure or the CD characters? That's a great question. That's a great.
Interestingly, very recently there was a PV panel vendor in our office, and in fact, last week itself, he sent me some photos that he's procuring so that we can possibly explore that. Having said that, can the conversion rate be very, very high? Possibly not. But for some of the passive systems, like let's say if there's a secondary battery, or if we want to have an IoT device running with the help of that, so those things can definitely be, taken into consideration. So it will not charge the battery pack per se. It will take several days, but some of the passive systems it can power definitely.
It's a very
Awesome,
good point.
awesome. And we've got one more from Greg. So you guys are located in India, correct? QARGOS is based out of India. I'm assuming your engineers and everyone, they're all over the place, right? They're not just in one location. How does it work? Where in the world are all your participants in the design and engineering process? Where are all your engineers and everybody? And how does that collaboration on the platform work for you guys?
See, one of the thing which, yes, so the most of the guys are in India. One of the things that allows the platform is you don't need to be in front of the computer and you don't need to be in office. That is one of the capability, right? We can be sitting at different locations. We can give access to our vendors in terms of participation. So all those things becomes much more easier with the platform approach that we have. And also it allows the review process and review mechanisms to be much more streamlined.
Got it. Yep.
And Alok, while we are talking about some of these benefits, can you quickly shed some light on the overall benefits that you guys have realized because of leveraging ModSim approach? I know we talked about aerodynamics and battery. We didn't get a chance to talk about the chassis, also due to IP reasons. But if you were to summarize, some of the benefits that you guys have already realized, what would those be?
So I think, one of the things that when we were building this particular thing, idea was to keep the while optimizing the front axle weight and the rear axle weight, the front wheel weight and the rear wheel weight. So those weights to be optimized. At the same time, we wanted to have a lighter chassis. In the earlier phase itself, we tried to kind of, work with one of our large suppliers to recommend a material which can be leveraged to make it lightweight. And we simulated that back into the chassis, which allowed us to take the design decisions at the simulation stage itself, rather than trying to, bring the material and then make it and things like that. It also allowed the aerodynamic drags. They are far superior. There has been when we have done the aerodynamic study, we realized that the aerodynamic efficiency is 30% more than the regular vehicles. That's also something which we are also publishing that in the paper. And also it allowed us to optimize a cargo compartment. Previously, original design was 175 liters, by virtue of leveraging the ModSim approach as well as space optimization, we have been able to increase up to 225 liters, which is like, massive 50 liters above 175, like, almost 30%, 35% more than the originally designed and originally targeted.
That's a
Yeah,
big
and
jump. That's a big
Yes.
jump.
yeah, and that's
Yes.
pretty much the heart of the solution you're providing, which is the cargo capacity. Yeah, that's impressive.
Yes. One other thing which I would like to also bring in is as you rightly mentioned, Shri Krishna, is the democratization of the simulation and overall capabilities. Previously, there used to be a lot of dependency, like 10 years ago when I was with the previous organization, there used to be a lot of dependency on the design engineers being able to do CAD work or the design new concepts and
Mm.
things like that. And then passing it on to the simulation engineers to carry on those things. No longer we are limited to only design. An engineer can real time work with the simulation and improve the capabilities and understanding on different facets of engineering, different multiphysics and different component systems. So an individual can become much more capable than what it was possible 10 years ago, and that's all because of the ModSim approach, the integrated platform that we have.
Thank you, Alok. And in fact, that brings us to the perfect segue into the next topic. I know we are running over time, but maybe we can wrap up real quick. Um, can you very quickly talk about some of the, I mean, the slide says future work, but this was
It's already up.
this is already present. But
In
quickly talk
progress.
about what's going on right
Future is
now.
the present now.
Absolutely. So the team is already working on the liquid cooled battery design, the battery drop test, plastic cell holder manufacturability, and EMI EMC. All four of them we are working. Wind tunnel testing and validation. Already the aerodynamic study has been done. The workflow and the process has been set. The objective over here is to basically go and validate as we progress further in the year. We'll be doing the actual wind tunnel testing. But a lot of these areas, I think except one area, I think all of them we are already working on.
Yeah.
And we are developing the workflows on that.
Okay,
This
perfect.
is absolutely great. I had a great time, hearing some of these insights and what actually goes into the minds of, these bright minds who are bringing out such fantastic, products out there. So thank you so much for taking time out and, sharing this knowledge with us and our viewers. I know that I will definitely go back and, look at this presentation and kind of get some more, deep points. And I might be pinging you guys on, LinkedIn with some more questions. Hey guys, I just thought about this. What's going on? So we really appreciate that. Shri Krishna, any parting words for our viewers and
Yes, I do. In fact, I want to bring up a very interesting story, especially for the students who are just, entering the professional world, or, the junior engineers who are just getting started their journey with SolidWorks as their design companion. For those of you who don't know, Pranav actually participated in Formula SAE 2013 that happened in Lincoln, Nebraska, as a student using SolidWorks.
Nice.
And fast forward 11 years, he was on the main stage of 3D Experience World along with Alok, uh, releasing this world's first compact logistics vehicle, completely innovated with 3D Experience Works. And now he's the lead vehicle integration engineer. I mean, this is an amazing success story. So, Pranav, tell us, about the transformation that you have seen in the last 10 years in terms of
Yes.
your personal career growth, as well as, going from the traditional SolidWorks desktop to 3D Experience platform.
Yeah, definitely. And the journey is very fascinating. I didn't even believed at that point of time that I would be, developing something like a QARGOS F9 platform, which is first in the world, and showcase it on SolidWorks platform, 3D Experience platform. I would have never believed it. But then the software has evolved large from that point to today. That point of time, my role was mostly onto designing of the vehicle, but today it's much more. It's to collaborate with multiple teams. It's to do the ECN process. It's having program management, and all these things today are being provided by the platform to me. So it makes my life very much easier today to build something like this. And even I'm looking forward that 10 years down the line, how this is going to evolve much. I mean, is AI going to come? How much more automation is going to happen in simulation? I'm very enthusiastic to see that.
Maybe, 10 years down the line, we will be having a similar webinar with another image added to the right.
Yes,
Yeah,
definitely.
absolutely. No, you've absolutely come like, full circle, I would say, man.
Yeah.
Like, from being a student engineer and leveraging those tools and learning as a student and and then your years of experience in the world, and then you bring it and you launch a product like that. That's, to me, that's called coming full circle. Like,
Yeah.
it's so fantastic job on that. Congratulations on this journey to you and Alok both.
Yeah.
I think we should wrap it up.
Yep.
We probably have other meetings to go to. So so thank you everyone for being here. We can't wait to see you at our next episode. Please, with the link that's provided in the chat, go ahead and register, and we will see you in our next episode. Can't wait to bring more stuff to you.